All right, so in this lesson, we are going to identify and represent attributes of a function. So attributes are like qualities, like aspects of, like an attribute of a human, maybe their height or their eye color, or I don't know, if they have a mustache or not a mustache. Attributes are like descriptors, I guess, of a function. So before we do this, let's talk about some special domains and ranges. So remember that domains are x's and ranges are y. So right here, we know that the domain, in this first one, we know that the domain, it goes 3, 1, right? 3, 2, 3, 0.5, 3, 100, somewhere up here. So the x, let me just write these down to remind you. Oops. Like this would be 3, 2, this would be 3, 1, this is like 3, 0.5. The x is always 3. Y'all are good with that. Y'all understand that. We've done this. Now, what makes this different is that it doesn't have a topmost, it doesn't have a bottommost. It doesn't stop going up and it doesn't stop going down. It keeps going on forever that way and forever this way. So our range, remember our range are the y values. The range are y. This is going to be something called all real numbers. Like, it can be any number, because it just keeps going on forever, like positive and forever negative. It's just all the numbers, all the real ones at least. And let's look at this one. So 2, -1. Let's go -3, -1. 0, -1. Let me try to make that stand out a little bit more. Okay, so all of these have the same y. The y is -1. But if you look for the x, values, the domain values go forever this way because the arrow, and forever this way, forever in the negative direction, forever in the positive direction. So the domain in this case, the x values, are all real numbers. The reason why I say real numbers is because eventually you're going to have or encounter these things, these numbers called that are imaginary numbers, but you won't get to that till later. So right here, I don't know, I'll just start writing these 0, 0, 1, 1, -1, 1. Okay, so obviously things aren't necessarily like this is going to change. Like the 0 changes, the 1 changes, okay. So let's talk about the x's. Do the x's ever stop going left? No, they keep going forever. It's diagonal, but it's still going leftward and it's still rightward. So the domain, it goes forever that way. So the domain is all real numbers. The range, which measures how far up and down you go. Well, you keep going up forever, but you can't go down forever. Like the lowest it goes, the range value is 0 right here. And then it goes 1, it just keeps going up forever. So y is always bigger than the 0. And let's look at example number 4. The domain, which is x, range, which is y. So the x goes forever left and forever right. It's always going that way or that way. So all real numbers. And our range, which is y, keeps going forever up and forever down. It's diagonal up, but it's always going up and it's always going down in opposite directions. So this is also all real numbers. Remember, they keep going on forever because these are arrows. Arrows, arrows. Okay, so let's look at the actual work for the day. So here is a function. Remember the students and the schools, like if we do the vertical line test, if we do our vertical line test, we're not going to hit more, we're not going to hit this curve, this function more than like at 1 point. So we don't have to worry about it. These are all functions today. So let's talk about this function. The minimum, that means the lowest. We're talking about the lowest point, the lowest y value. So the lowest. This is the lowest it goes, which is -5, -7. This is the minimum. So -5, -7. Now the maximum is the highest y, the highest point. So right here is 3, 7. This is our maximum. That's the highest it goes. 3, 7. Okay, let's talk about our domain and range. So I always remember that domain is x, the range is y. So x, y. You know what, I'll just do that. So the domain is going to have something to do with x. The range measures the y. Domain. So do we ever stop going left? Yes, right here. Domain, do we ever stop going to the right? Yes, right here. So the domain is always between -5 and 3. And it can be the -5 right here. It can be the 3 right here. Cool. The y, does it ever stop going down? Yes. That's the furthest it goes down. Ever stop going up? Yep, right there. So it's always between -7 and 7. It can be both of those because those are filled in points. So y is bigger than or equal to -7, and y is less than or equal to +7. Okay, x-intercepts. X-intercepts are where your graph hits the x-axis. So like this is an x-intercept, this is an x-intercept, this is an x-intercept. I'm gonna put arrow. X-intercept. Intercepts. Sometimes you have more than one, sometimes you have none. In this case we have 3. X-intercepts. So -4, 0. -1, 0. And 2, 0. If you notice, for x-intercepts, the x can change, but the y is always 0. For the y-intercepts, we can see it right here. This is the y-intercepts, where it hits the y-axis. So this is 0, -2. This will be switched. I'm actually gonna make that a little bit nicer. This will be switched. So the y on the y-intercept can change. You can go up and down. You just will never move left and right. So the y can change, but the x will always be 0. Cool. Now what's the value of f of 3? That's how you say it, f of 3, not f times 3. If you ever see something like this, this means f of 3. F of 3. So f of 3. Just so you know, this is the x value. So I'm going to go where x is 3. The x is 3 here. Remember, this is our x-axis. The x is 3 here, and the y is 7. So f of 3 is 7. Let's try it again. Remember that this inside number is the x. So what is f of -4? So f of -4. Let's go to where x is -4. And what's the y? Well, the y, you don't go up or down, is 0. Cool. Now this time, it's asking, when does f of x equal negative 7? So it's asking what x has to be for the y to be negative 7. This is our y. But if you notice, like, this is our x, like f of this inside is x, this outside is y. Inside is x, outside is y. So it says, what's the x, basically, when y is negative 7? So let's go to where y is negative 7 here. And the x is negative 5. So when does f of x equals negative 7? When x equals 5. All right, when does f of x equal 0? So when is the y 0? So never up or down. So you want to go on this line. This is 0 right here. When x is, oh, there's a lot. When x is negative 4, y is 0. So I want to put this like curly bracket. When x is negative 4, when x is negative 1, and when x is 2. When x is all of these, the y is 0. Okay, we have one more. So minimum, remember this is